In this video, we are going to continue thinking about finding the vertex of a quadratic function, but we're going to find an alternative way. We're going to do it strictly from the standard form and not from vertex form. So first we're going to review what standard form and vertex form mean for a quadratic function. We're going to show how to find the vertex of a quadratic function, not by first converting it to vertex form, but getting it directly from standard form. And then we're going to demonstrate this on an example. So first, just remember that a quadratic function has the form f of x equals ax squared plus bx plus c. Remember also that we can put this function into vertex form to help us find the vertex. We get f of x equals a times x minus h squared plus k. And remember that h and k tell us what the vertex is. H is the x-coordinate of the vertex, and then k is the y-coordinate. Now, one of the other things you might have noticed from both of those forms of the equation is that we use the same letter a in both formulas. And I'll highlight that for you so you can see it in both formulas. And that is not a coincidence. Those two a's literally represent the same number. And actually, you probably noticed that when you were working on some of the examples in the activities, that you ended up with the same a in vertex form as you did in standard form. So as we've seen, we can convert any quadratic function to vertex form, which means that we can always find the vertex of a quadratic function. However, one of those things that you might have noticed is that converting to vertex form is inconvenient, and inconvenient is actually a pretty mild term. It's a real pain in the butt. So what we'd like to do is find a way to find the vertex directly from standard form so we don't have to go through all that pain and suffering just to get the vertex. So here's the strategy that we're going to use. We're going to write our function, our quadratic function, both in standard and vertex form. We're going to make each form look similar to one another and compare how a, b, c, and h and k work in both equations to see if we can find out some relationships between those numbers. We're going to set some of the corresponding quantities equal to each other that makes sense, and then use that to figure out what the vertex is going to be. All right, so here we have f of x in standard form, ax squared plus bx plus c. And then in vertex form, we have a times the quantity x minus h squared plus k. Now it looks like the simplification is going to be easiest to figure out on the right-hand side. So I'm going to go ahead and square out the x minus h. So we square the x to get x squared. We multiply the x and the negative h together and then double that to get negative 2hx, excuse me. And then we're going to square that negative h to get positive h squared. And then plus k. Then we multiply the a through that, so we get ax squared minus 2ahx plus ah squared. The plus k stays the same. And then I'm going to go ahead and group those together so that you can see how they look in standard form. So now both sides are actually in standard form. On the right-hand side, we get the coefficient of x squared is a, the coefficient of x is negative 2ah, and then the constant term is ah squared plus k. Notice that the a's match up, right? In both versions of that formula, you get a times x squared. So as I promised, the a in standard form and the a in vertex form are literally the same number. And now what we're going to do is we're going to go ahead and match up the other coefficients as well. Right? So the coefficients of x have to be the same. The b on the left has to be the same as the negative 2ah on the right. And the constant terms have to match up as well. The c on the left has to match up with the ah squared plus k on the right. All right, so again, these two expressions are equal to one another. So if we match up the coefficients, the coefficients of x have to match up, which means that b and negative 2ah have to be literally the same number, right? Because they're both the coefficient of x. And what we can do, we're interested in finding h, right? So we can use that equation to solve for h, because h is the x-coordinate of our vertex. So we get h equals negative b over 2a. And notice that we're now able to find the x-coordinate of our vertex using b and using a. So we have that the x-coordinate of our vertex is negative b over 2a, which is exactly the sort of thing we were looking for. Now we can match up the constant terms, so that means c and ah squared plus k literally have to be the same number, which means we can set them equal. Now let's see, we already know what h is, right? So we're going to solve for k, because k is the y-coordinate of our vertex. And also, I mean, we know what h is. H is negative b over 2a. We just figured that one out. So we can actually plug that into our formula. So instead of c minus ah squared, we have c minus a times, well, we square that negative b over 2a to get b squared over 4 times a squared. So we get c minus b squared over 4a. So that, because the a's will cancel each other in that second term. Now, if we want to make that into one fraction, I guess we can by taking that c and multiplying top and bottom by 4a and then combining. If you like it that way, that's fine. There's nothing wrong with that. But either form, the c minus b squared over 4a or 4ac minus b squared over 4a, both of those are just perfectly nice formulas. All right. So that tells us what our k is. Our k is equal to the y-coordinate of our vertex, which is k, is equal to c minus b squared over 4a, or, if you prefer, 4ac minus b squared all over 4a. So now we can use these formulas to actually find the vertex of f of x. Right? So here we have f of x equals 2x squared plus 12x plus 5. Now, if we want to find the x-coordinate of our vertex, we need to know a and b. A is equal to 2, that's in front of the x squared. B is 12, that's in front of the x. And so our negative b over 2a, which is, remember, our x-coordinate for our vertex, is then going to be, our b is 12 and our a is 2, so we get negative 12 over 2 times 2. And we simplify that to get negative 3. So very quickly, we're able to get the x-coordinate of our vertex. Now, if we know c is equal to 5, which means that if we want to find c minus b squared over 4a, we just put in 5 for c, we put in 12 for b, and then we put in 2 for a, and then we end up with, when we do a little bit of arithmetic, we'd end up with negative 13. Now, one of the things you might notice is that the formula for finding the x-coordinate of our vertex is pretty easy to remember. Negative b over 2a is pretty straightforward. The one for c is a little bit more complicated. But if you don't want to, or not for c, but for k, for our x-coordinate, or the y-coordinate of our vertex, that one's a little bit more complicated. But if you don't want to remember that one, turns out you don't have to, right? We know the x-coordinate of the vertex is negative 3. And we know we can find the y-coordinate of any point on our graph. If we know the x-coordinate, we can just use the formula for f of x. So we can go ahead and use that one in the same way. So if I want to find the y-coordinate when x is equal to negative 3, I just want to find f of negative 3. So f of x is 2x squared plus 12x plus 5. So f of negative 3 is 2 times negative 3 squared plus 12 times negative 3 plus 5. Let's see, when we square 3, we get 9 times 2 is 18. 12 times negative 3 is negative 36, and then plus 5. And then when we simplify that, again, we get negative 13. So if you want to memorize the y-coordinate of the vertex and use that formula, perfectly fine. If you just want to take the x-coordinate of your vertex and plug it into the function to find the y-coordinate, you will find the exact same number. So our vertex is at x equals negative 3, y is equal to negative 13. All right, so it looks like you are ready to work on the activities now. The name of the activities is the application of quadratic functions, and you can find that on the PDF file included with this video.